Greetings, guys. This is just a walkthrough of some vocabulary. Some of it you should be familiar with, others of you're not. So, right now, what I need you to do is pause this video and then go to Canvas and pull up the circles vocabulary thing on the circles post. It's the very first Desmos link. Pause it, and once you've got that open and you're started, go ahead and open this up again. I'll wait for you. Okay, now here's what we're going to do. We're going to be talking about circles for next little bit, and a lot of this is vocabulary. In fact, that's the big thing you're looking at today is vocabulary. We're going to start off with basics. Do you know how to name a circle? And I'm not talking like, oh, it's Harry or Tom or not. No, this is circle F. Okay, I would call this. Whoa, that's a little weird. Sorry, I'm writing on something. Circle F. And since math people, we're not very good at writing words like that, we use a symbol for a circle. See if I can actually make a good circle. Oh, that's horrible. I'm going to erase everything here. We would call this circle F, and the symbol we use to stand for circle, because we don't like to write words, we like symbols for everything. We would write circle with a little point in between, there in the middle, and we would start circle F. And we call it F because this right there, that's the center of that circle. Every circle is named after its center. So yeah, do I know its name? Sure. And its name is circle F. Okay, great. Now, you're going to need to complete this, so don't just watch the video. Actually be walking along with me on every single one, or do it on your own later, or do it without watching the video. Either way is good. Now, it says trace segment AC in the triangle. So AC. Oh, that's this segment from here all the way to there. That's segment AC. I'm going to change a color on that to something a little better. So say that I like. There we go, AC. What's the name of that? Well, that segment happens to be a diameter, okay? A segment that goes from one side of the circle to the other side of the circle and passes through the center is called its diameter. Half of the diameter, like AF, that would be the radius. A chord is something like this. So let's keep going with this. Oh, I got it right. And see, this does correct you if you get it wrong. Okay, so I'm going to move on. What's the name of the segment FB? FB, where's FB? Oh, FB, that's right there. Oops, I want to select this. FB is there to there. Do I have to do this on everything, a single slide? I might have to. FB is F to B. Okay, and that is called not a circumference, a chord, a diameter, but this is called a radius. Now, a relationship. FB is exactly half as long as AC because AC is two radiuses. In fact, FA is a radius, FC is a radius, ED is not a radius. Two radiuses make up one diameter. So let's submit that. Great, I got it right. Okay, what's the name of ED? ED is down here. Sorry. I guess it's going to make me do that every single time. ED is right there. ED is a chord. A chord is just a segment that goes from one side of the triangle to the other side. So both of its endpoints are on not one side of the circle. It's a segment whose endpoints are on the circle. Now, technically, AC is a chord. AC is a special kind of chord. Any chord that goes through the center is actually called a diameter. But ED is just a run-of-the-mill chord. So let's go. Okay, so let's move on. What's the name of angle BFC? BFC. BFC. Well, BFC goes from B to F to C, just in that order. See it? BFC. That is what we call a central angle. Any angle whose vertex is at the center of your circle is called a central angle. Pretty easy to remember. Vertex is at the center. It's a central angle. Cool. Submit that. Great. Okay. Drag point P somewhere on the triangle. So I got to do a point. Draw point P. Okay, so I'm gonna draw it right there. Doesn't matter where you put it. That's point P. Now it says, use the straight line tool to connect point P to point E. Okay, so if I click point P, I'm going to undo that. If I connect point P to point E, I get that. And if I connect point P to point D, hey, that makes another kind of angle. See it? Angle EPD, like that. This is what's called an inscribed angle. An inscribed angle is any angle where the vertex and the two endpoints are on the circle. Okay, in fact, anything that's inscribed, anything whose endpoints is on the circle would be called an inscribed shape. Like I could make this here, I could go, there's that, that's an inscribed triangle. Okay, maybe not going outside like that, but you can see the thing. An inscribed angle is any angle whose endpoints, the endpoints would be right here and here, and whose vertex, that's the vertex, are all three on the circle. That's an inscribed angle. Okay? Now, let me pause for a moment. If you haven't already, you might want to pause this and copy this figure down in some notes and then start making some definitions. So far, think of what we've gone over. We've looked at naming the circle, circle F. A diameter is a line that goes from one side of the circle to the other and goes to the middle, goes to the center. A radius is half of a diameter, or the segment from the center to the outside of the circle. A chord is a segment from one point on the circle to another point on the circle. A central angle is an angle whose vertex right there is right on the center. An inscribed angle is an angle whose vertex and whose endpoints are on the circle. Okay, so there's a lot of vocabulary in here. Okay, I would copy this down, pause the video, copy it down, make some notes. Something you have next door to keep some anyway. Some notes for a circle. Now, it says trace the edge of the circle from point B to point C. Okay, from point B to point C. So if I was going to go point B, oh, that doesn't look very nice. Point B to point C. That's not an angle. It's not a chord, because a chord is a segment. This is actually an arc, not like Noah's Ark. Like that's A-R-K. This is an arc. An arc is a piece of a circle. This, in fact, is a minor arc. A minor arc is an arc smaller than half a circle. So that's another definition. A minor arc is any arc that's smaller than half a circle. Okay? Okay, so the name of this arc, arc BC, that we had, that was here, it goes from arc B, from B to C. The name of this arc with the symbol, there's a new symbol you ought to know, is arc BC with, it's not a line, it's an arc over the top of it. That's how I would name that arc, BC. You'll always name an arc by where it starts and where it stops. So here's a question to think about. If I say arc BC, how do I know that it's going from B to C that way and not B to C? Oh, that's horrible, but we'll deal with it. B to C that way. Well, this is the reason. Let me show you one more example for a second. Let's look at this. This says, trace the edge of the circle from point A, okay, through point B. So from A through B all the way to D. You can probably do better than I can. I hope you can do better than I can. That's as good as I can do. That is actually what we call a major arc. A major arc is any arc that's bigger than half a circle. And here's how we name minor arcs and major arcs. Minor arcs are named like the last thing. They have a start and a stop. Major arcs we name with a start, like A, a stop, like D, and a point they go through, like B, with the arc symbol. Now, we could have also called this arc A, C, D, because that's an arc that starts at A, goes through C, and ends at D. So it's still start right here, stop, and has to go through a point that it goes through. We would never call this arc ABCD. We would never do that. We just call it by 3 points. A point that it starts at, a point that it stops at, and a point that it goes through. Okay? My major arcs. Okay, so let's look at this. Trace the entire perimeter. Oh, sheesh, it's going to challenge me. The entire perimeter. Well, the entire perimeter is going to cover the whole thing. So I'm going to start there and go all the way around the circle. We call that the circumference. The entire perimeter of the circle is called its circumference. Okay, cool. Cool, I got it right. Okay, what's the relation for the radius and the diameter? Well, the diameter is double the radius, so it's just 2 times r. Okay, diameter equals 2 times r. Guys, that's a relationship that you need to know. So here's the deal. If you know the diameter of the circle all the way across, you would divide it by 2 to get the radius. If you know the radius, so from the center outside, you would multiply by 2 to get the diameter. That's it. Okay, let's move on. This is another formula, and it's a formula that I know that you should have known for the Aspire test you took. What is the equation for the circumference? Well, the formula is 2 pi times the radius. 2 times pi times the radius. Or, I guess you could do this. Or, let me do this again. I could go pi times the diameter. That works also because 2 radiuses is the same as 1 diameter. So that's a formula to memorize, whichever one you know. I like 2 pi times the radius. I don't know. Pi times diameter is the same thing. Another relationship. How do you find the area of a circle? The area of a circle, that formula is pi times the radius squared. Pi r squared. There's really only 3 area formulas that the ACT and other things, and even the Tech College is going to make you remember if you go up there. How to find the area of a rectangle, base times height. How do you find the area of a triangle? Base times height divided by 2. How do you find the area of a circle? Pi r squared. Other than that, formulas are always given to you. Cool. And guys, that's it. You can play here and draw a circle or do whatever you want. Or you know what? You can say, you know what? That's not useful in my time. I'm just going to quit. Guys, make sure you make yourself some notes with the vocabulary of all the words we've gone over, and make sure that you do the second Desmos activity on the post. Okay, guys? See you next time. Bye now.